All right, welcome everybody. We're going to get started with Chapter 5, specifically 5.1, primary and reciprocal trig ratios. So you know this from grade 10 as SOHCAHTOA. We're just going to add one little extra bit that you didn't learn in grade 10. That makes it now grade 11. But the first half of this is probably going to be review for a lot of you, which is good. So we're starting off slow. And then the second half of today's lesson will probably be where the new bits are. So if you didn't get a chance to print today's lesson, you'll find it again in the content section under the Chapter 5 unit folder, and it's 5.1. If you didn't print it, that's okay. You can just pause and copy as we go and then listen and fill it out along with me. That also works. It's probably not best that you try to copy and listen at the same time. That's very difficult for a lot of people to do. Also have a calculator with you. Obviously, we're doing trigonometry. You're going to need a scientific calculator handy. All right, so let's get started. So right angle triangles. Basically, we have a right triangle, which is any triangle that has 90 degrees in it. I'll put the 90 degrees there. Let's call this triangle something. So the vertices are the corners of the triangle. So the corners, or the vertices, need to be labeled. And they're always labeled with capital letters. So vertices are given capital letters. The sides, the side lengths, are related to the opposite vertex. So the label that I'm going to call this side down here, I can call it EF if I wanted to. There's nothing wrong with that. But that's even too much as far as us to write down. We can get away with writing one letter down if we just call it after its opposite vertex. So this side down here is actually referred to as lowercase d because it's opposite vertex d. This side over here is referred to as lowercase f. And this side over here, longest side, as you can see, is referred to as lowercase e. Now, lowercase e also has another name. It's also referred to as the hypotenuse. And that's important because it's across from the 90 degrees. So sides are given lower case letters named after the opposite vertex. So that's basically our setup of any triangle in math, not just trigonometry, but in math in general. Angles. So when we're interested in an angle, we don't use the English alphabet because we've already used up capitals and lowercase for the sides and the corners. So for angles, we're using the Greek alphabet. So letters like theta, letters like alpha, letters like beta. You can keep going. They can all be used, gamma. So they're all available there for you to use in place of a corner. And that indicates the amount of degrees that are in that corner. So theta, I can't use another theta up here because it's already been used here. And if I did, it would indicate that it's the same amount. And I don't know that it's the same amount. So that's why I'm going to use a different symbol for the amount up there. All right, so that is how we label, in general, triangles in math. Now, you also learned in grade 10, from any given angle, what we have now are some further labels that can be made based on the angle of interest. So if I'm interested in angle F, so angle F is my corner of interest, so the theta symbol, this side that's across from the triangle is referred to as the opposite side. This side that is next to the angle that is being formed, so he helps actually form angle F, we call this the adjacent side. Now these two will flip if I was using alpha instead. Then this side, D, would be called opposite, and this side, F, would be called adjacent. So your perspective dictates which labeling that you use, opposite versus adjacent. But notice that irregardless of the corner you're using, the hypotenuse never changes. It's always across from the 90 degrees. So the hypotenuse is always along the side, it is always opposite the 90 degrees, and it never changes in the triangle. All right. So obviously, let's try a few different ones. So I'd like you to label triangle PQR and I'm going to put the theta symbol up there. So pause and go ahead and label the triangle appropriately, and also label opposite and adjacent and so forth appropriately. All right. Okay, so hopefully you were able to do that. So I'm going to put my angle P here. Doesn't really matter. Q will be there. I'm going to put my R up there. So yours might be P up here, Q down here, and R over here. It really doesn't matter. So R will be opposite capital R, Q, and P. So if that was my angle of interest, this is now referred to as opposite. This is now referred to as adjacent, and this side over here is the hypotenuse. So that's very, very, very important that you're able to do that at the beginning of every question, because that's going to dictate which one of these three primary trig ratios, ratios means fractions, that you're going to be using in order to solve for either missing angles or missing sides. So you have to be able to know, what does the question give me and what does the question require of me? We will always be utilizing 2 out of the 3 sides. So one of the sides will never participate. So in right triangles, the angles and the lengths are related by these certain ratios. You know them as the sine, cos, tan ratios. So better known as sine theta is opposite over hypotenuse, cosine theta, or short form cos theta, is adjacent over hypotenuse, and tangent, or tan theta, better known as slope, tan theta is opposite over the adjacent. And again, you might have remembered the mnemonic SOHCAHTOA in order to help you memorize these three primary trig ratio formulas. So super important that you understand that, for instance, sine doesn't utilize the adjacent, whereas cos doesn't utilize the opposite, and tan doesn't utilize the hypotenuse. So tan is actually used quite a bit because you don't need the hypotenuse. It's just rise over run, opposite over adjacent, which in other words is slope. So that was a quick review of your grade 10 setup. Now let's actually use it in order to solve for some missing amounts in these triangles. So what do we got down here? It's asking us to determine x, y, and beta. So basically it's saying solve the triangle. And when it says solve the triangle, what you are meant to do is to find everything that is missing. So of course you have SOHCAHTOA available to you because it is a 90-degree triangle. So that means you have your 3 trig ratios available to you, but you also have Pythagorean theorem because it is also a right angle triangle. So let's label it. So if this was little y, then automatically I know that this is vertex y. If this is little x, then automatically I know that that is capital X, and then I'm just going to put a z here. So we have triangle XYZ. If I was to write out the Pythag formula, small side squared plus small side squared equals longest side squared. So y squared plus z squared is equal to the hypotenuse squared, which is where the x is sitting. So that is the formula. It never changes regardless of what you know in the triangle and what you don't know. And of course, any triangle that you already know, the angles will always sum up to 180 degrees. So you have these 3 tools available to you to work with most triangles. So let's go ahead and solve for the things that we're being asked for. So we're asked for angle beta. Well, that's the easiest thing to find first, I think. So let's label it for beta dot dot. So you're telling the reader what it is that you're looking for. Beta equals 180 minus 90 minus 30. So we got 60 degrees there. That was pretty simple. Get that one out of the way. The second thing we can find. Now, the order you find things in does not matter. We just go for what's easiest first. So we can go for y next, or we can go for x next. Let's go for y. So looking for y, I'm going to use the 5. The 5 is opposite the 30, and the y is adjacent to 30. So we got opposite, and we have adjacent. The formula that uses opposite and adjacent is obviously tan. So tan theta is equal to opposite over adjacent. Tan 30 is equal to our 5 over our y. Now notice our y is in the bottom. We don't solve for variables when they're in the basement like this. So they got to come up and sit on the other side. Now, unfortunately, there's somebody who's already sitting there. He's got to be kicked out. So the tan 30 needs to be moved down to where the y is sitting. So the y is going to sit up here where the tan 30 used to be. The 5 doesn't move. Don't touch him. And underneath is going to be your tan 30. So let's see what we get here. In your calculator, again, making sure that you are in degrees mode, you're going to go 5 divided by tan 30, and you're going to get 8.66. All right, so 8.66, 025, 4038. Now, in trig, if we're going to use a number for another calculation, we don't round it because we don't want to carry on more error into something else. So right now, I don't know whether I'm going to use this number for something else. So I'm not going to call it 9. I'm not going to call it 8.7 just yet. All right, last thing we need to find is x. Now we have some options. So for x, I could do 5 squared plus 8.7 squared equals x squared. I could do that and solve for x that way. Nothing wrong with that, but I'm relying that this is a correct answer if I do that. Or I could say, forget that. I'm not going to use y. I'm not going to use the 60 degrees. I'm going to go back to my original information, which is the 30 and the side 5 and x. So I think that's safe. So again, 5 is opposite, x is hypotenuse. Opposite and hypotenuse is going to be sine. So sine 30 is equal to opposite divided by hypotenuse. This time again, x is on the bottom, the x comes up, the sine 30 goes down, they flip-flop, and again in your calculator, 5 divide sine 30 equals, oh look at that, it's double the amount. So we get a nice clean number like 10. Now when you've been asked to solve for multiple things, it's always nice to summarize. Therefore, angle beta is 60 degrees, x is 10, whatever those are, and y is, say, 8.7 if we round to one decimal place. It's always nice to summarize when you had multiple things that you needed to find. All right, so what I suggest you do next is copy out these two questions that we're going to do next and do your solutions, and then join me again, and I'll help take them up with you. All right, see you soon.